So number 11 says solve for x in the inequality 5x plus 2 divided by x minus 10 is greater than or equal to 3. Now I have a disagreement with how to solve this, but I'm going to show you my way first. So the first thing I'm going to do is turn the left side into a rational function. So f of x equals 5x plus 2 over x minus 10, and I'm going to have a vertical asymptote at x equals positive 10, so I'm going to go ahead and put that in. So there's my vertical asymptote, x equals 10. And then I'm going to have a horizontal asymptote. If I let x go to positive infinity or negative infinity, basically it's going to end up being 5x over x. So my horizontal asymptote is going to be y equals 5. So we'll go put that one on. And now I'm going to go find the X and Y intercepts. So the x-intercept is going to be when f of x equals 0, so that's 5x plus 2 over x minus 10. So really all I need to do is set the numerator equal to 0, so 5x equals negative 2, x equals negative 2/5 or negative 0.4, so we'll just say put it right there. And then the y-intercept is when x equals 0, so if I put 0 here, 0 here, that's 2 over negative 10, which is negative 0.2. So I'll put that here. And then I need to find one more point that's relevant to this problem. And that's when does this equal 3? So I'm going to multiply both sides by x minus 10, so that's going to give me 5x plus 2 equals 3x minus 30. So subtracting 3x from both sides, 2x, subtracting 2 from both sides, negative 32, x equals negative 16. So that's going to be right about here. And I'm going to go put in a horizontal line at x equals 3 and make it solid. So x equals 5 is the horizontal asymptote, x equals 3, we already got this labeled, so at negative 16 we're going to be at 3. So if I sketch this in, I'm going through this place where I go through y equals 3, y equals 5. So, and then I'm going through negative 0.40 and 0, negative 0.2. And then I'm going to head toward the vertical asymptote. And then if we do f at 11, that's going to be 55 plus 2 over 11 minus 10 is 1, so 57. So it's going to be way up here, so we're going to be coming down like that. So we're asking when is the expression greater than or equal to 3? So the solution set here is parenthesis, not bracket. So negative infinity up to and including negative 16 because it's greater than or equal to. So to negative 16, so that's a bracket, union with, I can't actually touch a vertical asymptote, so I go a little bit more than 10 up to positive infinity. And we'll go look at their solution. So they solve this a little bit differently. So they immediately subtracted 3 from both sides, got a common denominator, and consolidated this rational expression into this is greater than or equal to 0. After you do that, I still think you have to sketch it to figure out where you're hitting 0 and where you have the vertical asymptote and you're above, and here you're above, so you're greater than 3. So you could do it the way they did it. I like doing it this way. Either way, you're going to get the right answer, but you pretty much have to sketch the rational function. So here it is in the calculator. I put in the rational function. I did f of x equals 3 for that line, and then the vertical asymptote is y equals 5. Here's the vertical asymptote. So we can see that we're equal to 3 right here and below, so negative infinity to negative 16. Then we're not meeting the definition in between negative 16 and negative 10, but once we jump over, or positive 10, once we jump over x equals positive 10, we're going to be greater than 3 for the rest of infinity. So that concludes this video.